My name is Akash. I am a UC Berkeley student still, finishing up my last year. I used to work at Interstellar, and now I'm working on some interledger research. I have my very talented panelists here. We have Evan from Interledger and Ripple, and we have Nate Rush, who's an undergrad. He's at UPenn, and he did research at Ethereum. We have Dan Robinson from Chain, which is now Interstellar. And we have Mo Dong from Stellar. So to start off this panel, I'd like to bring up a discussion of what is exactly layer 1 and what exactly is layer 2. So panelists, please chime in.
Yeah, I guess I'll jump for it. Can you guys hear me? All good? No? Louder? Okay, cool. Yeah, so I think it might be cool to just talk about like what our goals are in terms of scalability before we go into the layer 1, layer 2 stuff. Obviously, scalability means increases in capacity in some sense. And I think like one theme throughout this talk that we'll probably hit on a lot is, especially when talking about layer 1, layer 2, is essentially what assumptions are required to give us these increases in capacity, and kind of under what assumptions are things secure and decentralized. As a side note, when I say increases in capacity, like personally, when I'm talking about scalability, I guess what I'm talking about is the classic one, transactions per second, but also in terms of state size. And you can kind of think about that as like, how many things can we have, stored on the blockchain at once. Yeah. So just to, I guess, start the combo.
I'll jump in and, is this on? Can you hear me? All right. I'll jump in and say, when I think of scalability, I mostly think about transaction throughput, so that's the transactions per second that people often mention, as well as latency. I think that's a really big problem. If anyone has ever actually tried to use a blockchain, that's quite a painful experience in many cases. So I think there's an element of, can we speed this up and make it just more usable in that way?
So one thing I do think we'll all agree on, maybe, or we can fight about it, is when we talk about layer 1 scaling, hello? Yeah. If we talk about layer 1 scaling, we're not just talking, or nobody here would argue that all we need to do is just sort of increase the block size or increase the size of the data that everybody has to process, because ultimately that doesn't scale in the sense of like literally if everybody has to be processing every transaction, everybody's using the blockchain has to process every transaction, then you're just not going to be able to get that kind of the kind of throughput that we want, while still preserving kind of the trustlessness that we want, right? So, and I think Nate here is I think going to be sort of the biggest skeptic of layer 2 scaling and most in favor of layer 1 scaling. But when you say layer 1 scaling, you're referring not just to raising the block size, but also to stuff like sharding and other sort of in-protocol supported scaling, right?
Yeah, totally. So I think you bring up a really interesting point in that in some ways, when we say increases in capacity and like scaling, we kind of, there's some easy ways to do it that kind of give up on what, the entire goal of the space in a way. For example, if we made the blocks, 70 gigabytes big, oh, great. We'll have so many transactions per second, but at the same time, is that going to be able to run on consumer hardware? Probably not, depending on what you define as consumer hardware. And so, in some sense, we have to be careful that when we're talking about scalability, we also keep in mind that we also care about other things too, like decentralization, whatever that means, and security as well. Yeah, so I'm definitely going to be a proponent of second layer or first layer scaling solutions, probably, and also I probably won't be satisfied with them if they're just make the blocks huge and have super nodes processing everything.
We should probably go back to Akash's original question of what do we mean by layer 1 and layer 2?
Yeah.
Well, I can maybe like give a very simple classification on that. That is, for layer 1 scalability, it's like we are talking about the consensus. Basically, how can we make the consensus process faster and put more transactions in it? That's like the two things that we do on the layer 1 scaling. But the key thing here is that it always involves the consensus process. So, for example, sharding can be considered as layer 1 solution, and also things like new consensus algorithms, and maybe even like a little bit more centralized algorithm like TPOS can be considered as layer 1 solutions. Now, for layer 2 solution, the key insight here is to use blockchain as a settlement layer. and move most of the transactions away from the blockchain without actually incurring this global consensus process. Because whatever the consensus, however fast the consensus algorithm are, the overhead of communication delay of decentralized or distributed system is always going to be there. So there's kind of like a ceiling on the layer one solutions layer one solutions scalability. That's why like we're starting to investigate more towards the to the layer two solution, which is like bringing the transaction off the blockchain. And for layer two solutions, some of the example technologies people have been talking about, including state channels, in the form of simple payment channel, or in the more complex form of generalized state channels, and also things like side chains, and also interactive computing. All these things can be classified as layer two solutions. That is like use the blockchain as the final settlement layer, but most of the transaction is optimistically put off chain.
Okay, so Nate, why do you consider sharding to be a layer one rather than a layer two solution? Given that you're taking the transactions off of the blockchain that everybody has to have consensus on, you're putting them on some other blockchain. There's some process for essentially like reconciling all of these things together. But how do you distinguish that sharding? Why would you still call that layer one scaling?
Yeah, so I guess the kind of distinguisher for me is like the question of in the protocol versus out of the protocol. And it kind of kicks the can a bit because like the word protocol isn't actually very well defined at all. But in some sense, the idea is that the blockchain has awareness of some state. And essentially, in sharding, even though any individual shard might not have awareness of the entire system at any given point in time, the shards as a whole kind of collectively have an awareness of what's going on, if that makes sense. And so I distinguish, rather than using the word consensus, I might say it's in the protocol versus on top of the protocol.
But so, I mean, Ripple has built-in support for payment channels. Like that's a first-class feature. It's called payment channels in the implementation. That's built-in support for payment channels. Does that mean payment channels are a layer one scaling solution?
Yeah, it's a lovely question. Okay, so I guess let me actually change my answer a bit. Yeah, you're getting to the heart of it. I would actually define, I think, like one kind of key distinguishing feature when we're talking about these things. As I said before, like the way we can understand them is in terms of the assumptions or the properties that are required to make these things secure. In some sense, layer two solutions require interactivity in some sense. And one kind of key distinguishing feature about what's in protocol for me is that there's no interactivity required on behalf of the user. A real quick example of that, right? For example, in the Lightning Network, this is an example of a kind of a second layer scaling solution. It requires users to be online, kind of monitoring their channels at any given point in time, even if it's in protocol, to make sure that their coins aren't stolen. We can kind of get into the details of that as we go along, but I think for me, kind of one main distinguishing feature is this interactivity that's required in second layer solutions.
To add on to that, aren't there also ways around sort of that interactivity aspect? Couldn't you have somebody else being responsible for that interactivity, and basically you have non-interactive layer 2 scaling just by having like watchtowers, for example?
Yeah, someone's watching. The watchtowers are, right? Even if it's not interactive necessarily on behalf of the user, someone needs to be online on their behalf, and they're the user even if it's by proxy.
Someone is like miners or validators, right?
Yeah, so in that sense, does a layer 2 protocol become a layer 1 protocol?
Yeah, it's a great question. I think, so here's what I'll say. In certain cases, I think the lines begin becoming a bit wavy. I'm sure we could design kind of some fancy layer 2 protocols that maybe use, zero knowledge proofs or whatever magic you want to kind of make things non-interactive in a way. And in that case, you start getting into places where we're a lot closer probably to layer 1 scalability. And I guess the point that I'm trying to make is that it's probably more of a spectrum than just there's that and that. And in general, the way we can kind of analyze these things is under what situations do they provide good guarantees to users? Because in the end, that's all we really care about.
Right, so to sort of transition to something more high level so that we don't get too into the weeds. What are some scenarios where you might find layer one scaling better than say layer 2 scaling? And would you say this is like for the majority of scenarios, or are there scenarios where layer 2 just happens to work really well? I'd love to hear your thoughts.
This this is a great question, but it's unfortunately kind of goes back to like what is layer 1, layer 2 scaling. I think one way to think about which scenario is better suitable for layer 1 scaling, or which scenario is better suitable for layer 2, is that for layer 2, the key concept here is that the intermediate state doesn't matter that much. Right? So for state channel, you have super high frequency interactiveness and all that stuff. But finally, when you resolve it back on chain, many of the state doesn't actually matter anymore. And for sidechain, the same thing. You create a chain that is on the side of your blockchain, and you keep committing the block root to the main chain. And finally, when everyone is like done with the app, or like when someone is trying to withdraw the state, it is basically exiting from the sidechain. So so now come back to the question of like which use case is more suitable for layer 1, which use case is more suitable for layer 2. So if you are more focusing about like letting your state pertain or letting your state be consistently available to all people involved in this blockchain, then you should be looking at like a layer 1 solutions, or you should be actually putting your transaction onto the underlying blockchain. If it is more interactive and the state is more transient in nature, then we should be like looking more towards the layer 2 solutions.
So like for a scenario like value transfer, like what would you say is the best scaling method?
I might actually push back a bit and just present kind of, I guess I'm going to call it a pipe dream, like a dream of a possible future that would be really cool if we could get there. In some sense, we think that layer 1 scalability solutions can provide kind of the most robust guarantees to users. But we also know that in some cases, like layer 2 scaling solutions, for example, state channels or payment channels or Lightning, et cetera, really help out on latency, as you kind of mentioned. It's kind of an important consideration. And I think for me, kind of one of the main goals would be we use things like what we call second layer scalability solutions now really as solutions for latency. And more than anything else. And where we're actually doing our transactions, though, ends up being on first layer, just for the security reasons.
What about privacy? If under your definition even of layer 1 scaling, right, still everything's happening in public, right?
Yeah, fair point. Yeah, I think I would argue that privacy is a separate problem that also needs to be solved. In some sense, you do get some privacy benefits from keeping some of the intermediate state off chain, but I think that's something that we can solve on our first layers as well, in protocol as well.
I want to go back to the previous point you made, and just like, I actually think it's important to marry both scalable layer 1 solutions with scalable layer 2 solutions. So specifically with the value transfer example, I think a lot of times we're going to see there's many repeated transactions with the same parties. Those make a lot of sense to do off-chain in things like payment channels. Payment channels are bilateral examples. There's also multilateral examples like side chains and things like that. So I think that makes a lot of sense to move a lot of those transactions off-chain. At the same time, even if you're doing that for latency or transaction throughput reasons, you still want the layer 1 blockchain to be pretty fast and pretty cheap. Otherwise, you end up with a really bad experience for even just opening and closing these types of relationships. So if you want to move money into a payment channel and you have to wait an hour or hours to do that, this is a terrible user experience. That also means that if you want to deposit more money into that or withdraw money from it, it's again that really long delay and maybe very high cost. So I see it as it's important to have both pretty fast, pretty cheap transactions on the blockchain, even if you're only using those to set up payment channels and close them down.
I wonder if anyone here is familiar with like the counterfactual like style of instantiating like payment channels and the likes of those, because apparently you can do stuff completely off-chain until like you just want to close the channel.
So yeah, so we are working with L4, and L4 proposed a counterfactual project, and Seller proposed Seller, which is like our C-channel construct. This is two concurrent work that both enables what we call virtual contract, what L4 is calling counterfactual instantiation. So the idea is that if you're opening a state channel, if there's no state race among the state channel, like payment channel, you cannot do this. But if you're doing like a chess game that is some payment is conditional, it depends on, then that chess game doesn't have to have an on-chain anchor until there is a possible dispute or settlement happens. So that is kind of like the thing. That is possible. Now, I guess like just to have a methodology of thinking about this question, that is, how are we thinking about layer 1, layer 2 solution? I guess one question to ask is that, first of all, how much scalability do we actually need on blockchain, right? So this is like the grand question or grand challenge that we all need to think about. Is it like 20,000 transactions per second? How fast is the latency? Is it like 1 RTT, hundreds of milliseconds, tens of milliseconds, or like even 1 second, 10 seconds is enough? So these kind of questions actually print a frame about like the things that we can draw inside of this frame, right? So if let's say the conclusion is that we need, let's say, hundreds of millions of transactions per second, then we know that as a principle of decentralized system or distributed system, it simply cannot have that kind of scalability because for a simple decentralized system without shard, the transaction processing capability is bounded by one machine. But even with shard, the Amdahl law dictates that as long as you have small percentage of on-parallel job, the embarrassing parallel way of parallelizing things kind of quickly fails, and like this entire scalability improvement curve flat out as even if you add more and more parallelization in it. So I guess the question for all of us to think about, and maybe we can discuss, is what each of you guys think about like the ultimate goal of blockchain scalability is. Like, where is the mass adoption goal?
So I'm very focused on value transfer and payments, exchanges, things like that. And I think a lot of people like pointing to Visa's numbers as like the numbers to beat, 50,000 transactions per second. I think that is way, way lowballing it by many orders of magnitude, because if what this whole space is kind of marching towards is the idea of an internet of value or something along those lines, I think what we're going to see is value transfers on the scale of internet packets. So I don't actually know how many packets per second the internet processes. I'm not sure that's like a quite knowable number, but I looked at some point how many transactions.
It's 53 terabytes per second, roughly.
Which is not that's actually different though than packets per second, which is to me the interesting question, because we're talking about like packets are individual transactions. So the main point I wanted to make was just like my home router, like your cheap kind of home router, can do something somewhere between 100,000 and 1 million packets per second. And that's just what you have at home. That's not commercial grade or anything. So when I think about packets per second, that's the way that I'm thinking about it. And then with latency, I think that's also super, super important, where I think if you want to make transactions across the world, you want to have very real-time experiences. People notice if you start taking too long. And in traditional value transfer in the banking system and whatnot, we're used to days, which is a completely unacceptable experience. But I think if we're moving towards this internet of value idea, we want it to happen. It should happen at the speed of the physical network latency. Like when we think about payment latency and interledger, we're worried about the constraints of the speed of light. At a certain point, you can't move faster than the electrons going physically from me to you. But I think that's the way we should be thinking about payments, at least. Other types of transactions may be different, but that's the way I think about it.
Cool. Yeah. Interestingly enough, I'm, I guess, less interested in payments and kind of more interested in like the the general space of decentralized applications. Again, whatever the hell that means. But yeah. So I guess I'm somehow like less interested in like very specific scalability numbers or a specific target to aspire to, rather than I think that our like aspirational goal really should be as scalable as of a layer one as we possibly can have, right? For essentially the reasons that you lay out. Even if you have a lovely layer two, if your blockchain itself can only support 14 transactions per second, not that many state channels are going to exist on it. And so I think reasonably, as protocol designers, our goals should be as scalable of a layer one as we can possibly make it. And then if it's still not enough, then maybe we compromise on security from there.
Oh, you don't compromise security for layer 2. Yeah, that's a key thing.
Maybe we could get into it, but there are additional assumptions you have to make. So you don't compromise on security under some set of assumptions, which it turns out may or may not be reasonable. Yeah.
So I mean, what can you describe a little how sharding scaling works? Because the idea here is you're saying not everybody's processing every transaction, but you're still saying in some sense you're calling this layer one.
Yeah, yeah. So I guess.
What are you talking about?
Yeah, great. Fair point. Fair point. Yeah. So I'm gonna give. I guess I'll attempt to give like a high-level kind of summary of the ideas behind sharding. So as of now, blockchains. We got a single chain of blocks going along. Every single full node verifies all of the blocks in the blockchain. That's pretty much how it works. The idea behind sharding is essentially imagine if we had some set of people who are maintaining the network, so you can think about them in proof of work as miners or in proof of stake as validators, and we essentially shuffle them around and assign them to specific shards. And here when I say shards, I mean you can imagine baby blockchains in some sense. How these shards are arranged is an open question. Is it a tree? Is it kind of some amorphous graph of shards where they can communicate? But in any sense, we have essentially autonomous blockchains advancing that share. They essentially pull their security from a global, let's call it, validator set. On top of that, you need to have the ability to essentially send transactions between shards and move validators between shards. And once you have that, you have what I would classify as a first layer sharding solution.
But so you don't, do you have at any given point like a consensus as to total ordering of all transactions across all shards?
Definitely no. Yeah, you would definitely not kind of enforce a total order on all transactions across all shards, because if you're doing that, we're kind of right back to where we were in the beginning with just one blockchain.
I mean, I think maybe this is a definitional issue, but to me, like, again, once you get beyond essentially one blockchain with total ordering consensus, everybody sees all of it. We're talking about different layer 2 things, and Plasma set is different from state channels, or different from side chains, different from sharding. But these are all essentially ways of making sure that you are able to trust the security of this without you seeing everybody else's state.
Yeah, no, yeah, I think you're right in that that goal specifically is very much the same. But the differences kind of lie in the assumptions we make about the validator set, and like for example in Plasma, your validator set isn't the global validator set of the actual blockchain itself, right? Which is hypothetically more distributed, and we've got a larger pool, and we can make kind of nicer assumptions about it, I guess I'll say, which is in my opinion, where the security comes from. Yeah.
So Dan, I'd love to hear your thoughts regarding sort of how Plasma compares with sharding, because essentially Plasma is creating these application-specific blockchains, and you have sharding, which is sort of taking the global state and splitting it up into these child blockchains that eventually converge to one. So how are these ideas different? And maybe you can elaborate more on some of the better side of Plasma versus sharding.
So yeah, so I don't want to get too far necessarily into technical details of it, but as sort of the broad way I would think about Plasma for those who aren't familiar with it, and the way it differs from sidechains or sharding, is that in Plasma you have essentially a sidechain, but it's one where you don't necessarily have to depend on whatever process is producing these blocks. So you don't have to trust that there's a set of validators, and that some percentage, a sufficient percentage of them are honest. You can actually have a validator, an operator who's producing these Plasma blocks and maintaining this sidechain that's completely untrusted, and you still preserve safety of any funds that you have on the chain. And that's not true about sharding or about sidechains. That you're essentially trusting this set of validators for the layer 1 for this layer 1 security. You basically have to trust the validators. If they're malicious, then they can potentially attack you. So the advantage that Plasma gives you then is that you can have a Plasma chain with a single operator and not have to trust them. So much like how in a state channel you don't have to trust your immediate counterparty.
Are there slowdowns when you implement, say, more than just a single operator on Plasma? Or are there if I decide I'm going to put a proof of stake, BFT consensus layer on top of that, does it essentially become sharding in a sense?
Yeah, and I think the more you try to put into sort of we're going to make sure that Plasma blocks are produced by this distributed consensus, you eventually get to just basically sidechains, where you're saying, we might as well just trust that this process is producing blocks. But I think mostly sort of the sweet spot for Plasma design is when you have one sensible single operator who you sort of trust for liveness. You say, I assume they're probably going to stay online, and it might be a little inconvenient if they go offline, but I'm not going to trust them, with the ability to steal all my money. So that's again where I sort of see Plasma fitting in. Plasma, I think, is indisputably sort of a layer 2 solution, in that it's something that, like Nate said, you're sort of depending on this interactivity, you're depending on this exit game, you're depending on some synchrony assumptions that I'll be online once a week. But you're not depending, and I kind of like this about it, you're not depending on sort of the honesty of a set of validators.
Another thing I was sort of wondering about was, and I think some of the audience might benefit from hearing this, is in terms of what kind of transactions would I be able to scale versus, say, a network like Lightning or a payment or value transfer network like Interledger, like what kind of stuff can I do differently?
Right. So
Go ahead.
yeah, so Plasma is kind of like an overloaded word these days. Like you have all sorts of flavors of Plasma. You have Plasma, MVP, you have Plasma XT, you have Plasma Cache, you have Plasma. You know, I don't even keep I can't even keep track of things. But the key idea for Plasma is that it's a sidechain construct. Okay, so but it's a sidechain construct with the capability to attribute fault to malicious block proposers. So it's just that. It's the high-level idea of Plasma. So you can basically, if some block proposer in the Plasma chain is trying to produce a false block, there's a smart contract that is sitting on the Ethereum blockchain dictating what is the correct rule of producing blocks. And if someone sees he's behaving maliciously, that fisherman or whoever can just submit that fraud proof on-chain and slash the Plasma block proposer's stake, basically. So. Sorry, what was the question? Oh yeah. So what kind of things can be scalable on Plasma chain? So for this kind of a sidechain construct, currently the implementation is mostly oriented towards payment. Implementing EVM inside of a Plasma is relatively hard because there is a problem about who owns that virtual machine state. Right, so if you have a state, you have a virtual machine, you have a smart contract that is running inside of a Plasma, when you're withdrawing the smart contract, you're not only withdrawing tokens. Withdrawing tokens is relatively simple because the token has a single ownership. There's no state risk. Again, the state risk is a very key concept in the layer 2 construct. When you're withdrawing the smart contract, it's very hard to tell that who has the right to withdraw this smart contract. Let's put like some auction contract on Plasma, and when people are doing auction, can people like withdraw all the result of the auction to the main chain? What if someone submit a new bid or something like that? So this kind of a thing is relatively hard on Plasma because it requires you to implement a EVM inside of a EVM effectively. And however, but it's I think it's definitely possible that we just need to have some more time to research and maybe change the virtual machine construct. And for state channel, things are a little bit easier. For example, in Stellar, what we can enable is actually not only just for payment scalability. One key feature from Stellar is that we enable generalized state channel. That is, you can actually run complex smart contract also off-chain. So the idea here is that for the smart contract state, you can have a virtual contract instantiated, and then for each of the state progress of the smart contract, you can just have all the participating signing on that and validating the state is valid. So that's kind of like the quick comparison here.
Yeah. So another thing to just zoom out a bit from the technical details is, do you guys think that maybe layer 2 or layer 1 might speed up adoption in a sense? Will they perhaps change the interfaces by which users interact with blockchains?
Yeah, I mean, in one respect, latency is kind of if we're willing to classify latency as a scalability thing, latency, it seems quite important. Quick transaction times are nice. You guys are all users, I'm sure, of something, and if it's quicker, it's better, just like usually. And also in general, if we build platforms that can support larger decentralized applications, people will be able to build larger decentralized applications, hopefully helping adoption in some sense, if we decide we want to do that, I guess.
I do think that there are definitely some challenges that are unique, though, especially to layer 2 scaling solutions where, like for example, this requirement that you be online once a week to check something there's no real analog. When people try to explain how this works, there's not really a lot of analogies in terms of like user experience, where someone like has to go check something every once in a while, or just like, or through no other fault of theirs other than just being offline for a week, like all their money has gone. Like that's not a normal sort of payment experience. And so much like I think storing private keys or sort of like dealing with privacy coins, like those are maybe new user habits that we either have to build tools that make it easier to do, or educate users to do that. Although again, I think ultimately it is going to come down to like users shouldn't have to think about this. So there should be solutions like watchtowers or other things to try to kind of abstract this away so that you don't actually have to worry about, oh man, how long have I been offline? Is all my literally all my money going to be gone when I get back on?
Yeah, that's a great point. And I think you hit on a very good point. That is like the onboarding process of all these, including like layer 2 solutions, that is going to be super critical, right? So, but I think layer 2 solutions is definitely going to help in terms of adoption. How many of you guys have tried out like the application that we built using layer 2 at our booth? Okay, a bunch. Yeah, that's pretty good. So that kind of like application. So what we build is a board game, right? So if Alice and Bob come to blockchain and they play a chess, then what happens is that Alice will make a move. Yeah. Now we are all just waiting for the block confirmation time. Right? So that's kind of the user experience if we build a block application on a layer 1 blockchain. But if you do it as on a layer 2 solution, like the off-chain smart contract, you can do like Alice makes move, Bob makes move, Alice makes move, Bob makes move. If you haven't tried it, like find me after the panel, and I will show you how this works basically.
Why do you want to play chess on the blockchain?
Great question. So why do we want to play chess on the blockchain? You absolutely don't want to play chess on the blockchain if there's no money at stake.
Okay.
Yeah. So basically, this kind of a smart off-chain smart contract construct, what this is really powerful about it is it enables this kind of what we call a conditional payment, right? So you have Alice and Bob, they go onto blockchain and play some game. The first thing they do is Alice send Bob a conditional payment, a multi-hop cross-network conditional payment, saying that I'm paying you $0.1, but the payment is depending on you actually finally win the game. And Bob will pay the same thing to Alice. So now Alice and Bob doesn't have to know each other.
So Mo, I'm gonna interrupt because it might be going a little too into the details.
All right.
But,
but yeah, you got it. Just
I mean, yeah, I do think I generally agree maybe with Evan on sort of as far as applications that like the killer applications so far generally that we've seen are tokenization, exchange, and payments, right, on blockchains in general. And so yes, I do think it does enable a lot of really other cool things, but like there's a lot of design space there maybe that is yet to be explored, and the experience that hasn't been improved sufficiently. And so just improving latency for that. And this is why I think a lot of I think Plasma, doing Plasma for more complicated things can be really challenging, but really if you sort of limit your scope and just say, I'm building this for payments, I'm building this for exchange, I'm building this for tokenization, you can scale that experience a lot without really necessarily having to get into sort of the more complex stuff, which I do really like, and I think generally, yes, like decentralized gambling is very cool, but as far as sort of like the where I think you see the pain points most right now often is in payments.
Real quick, this is kind of a side point, but so it seems like you're quite pro layer 2 scalability in some sense. It seems like it's
I'm pro both.
Pro both, sure. Which includes pro layer 2. But
by the way, is anyone here like anti layer 1 by chance in terms of like is it not like realistic or?
Hopefully no. Yeah. So I guess here's my question to you. Building these things, it seems like this is kind of a major part of the Stellar protocol. Are you at all worried that the miners in your protocol are maybe not as nice as you are assuming them to be, and that maybe they just might censor transactions for users and steal money from users because all of their money is seemingly going to be locked up in these payment channels?
So so first of all, the money. About like miner censorship. Censorship happens on all sorts of decentralized systems. It happens even more likely in a centralized mining scenario, like if you were talking about the blockchain, layer 1 blockchains. For layer 2 blockchains, it's even easier to make it an open network, right? So you can, it's still a decentralized system. It's not like a single hub that is dominating this entire payment or generalized state channel network. You can, so what we envision is that there will be an off-chain service provider popping up, and there will be a decentralized network off-chain service provider. And just like you choose Xfinity or AT&T, you can choose different kind of off-chain service providers.
Sure. Yeah. So more specifically, my concern is imagine that the miners on chain specifically are, we kind of see them in general being more centralized maybe than we'd like them to in most major blockchains. Imagine they start censoring the settlement transactions of these state channels. So specifically what I'm referring to is we've talked about how state channels require this interactivity period, right? You have to be online and watching to make sure that your funds aren't stolen, okay? Now my question essentially is what happens if the miners, I don't know, because maybe they're not the nicest people in the world all the time, decide to go into cahoots with some users and essentially censor these settlement transactions and essentially the miners, in cahoots with users, steal money from people. Are you at all concerned about this? And do you have any suggested solutions to this problem at all?
So I think this is a general problem for censorship on base layer blockchain. So for the smart contract portion of layer 2 solutions, it's just another smart contract. It has some logic that may be infected by the censorship, and it's just so as every other blockchain smart contract. So yes, so I think that's a general problem of the censorship of the base layer protocol, and in particular for state channel solutions, yes. It may be affected by the layer 1 censorship, definitely, so as any other smart contracts.
So I would push back a bit in that, notably, the difference is that in a chess game online, let's imagine every single move is submitted to the blockchain. The game's not going to terminate, unless we build that logic in on chain in the same kind of way. Although if you did have a timeout, it might be. But my point is, in general, for example, payments. Let's talk about we have been. If I have my money on a blockchain, miners can't take it from me, whether or not they censor my transactions for the next 150 years, right? It's still going to be mined at the end of that as long as I maintain control of my private key. And that's something that's notably not true with state channels.
Oh, no, that is absolutely true, right? So, you deposit it into the state channel, that money still belongs to you. You need to have basically a process of settlement to get the money back. But that money, no one is taking that money away from you.
If miners censor the base chain for a few days or whatever your timeout period is, they can cause your channel to be exited in an outdated state, right?
So yes, that's the part that miner censorship can hurt layer 2. In this case, specifically a payment channel contract. But there are many other cases. Let's say if you're doing auction, you're doing a claiming of your NFT token, your crypto kitty is locked up somewhere. All these things can be done with this kind of censorship. So it's not to say that this is a unique problem of layer 2 solution, but censorship itself is a problem.
Yeah, right. That seems like your problem, Nate. What you were supposed to give us a solid layer 1 blockchain, and instead you gave us an amorphous, I don't know if it's a tree or what, design for sharding before solving the censorship problem that was supposed to be your problem.
Yeah, fair point. I think, yeah. You're right. It's on us. So I think you're totally right in that there are a lot of things that we could do on the blockchain that would be affected by miner censorship. And I think it's an incredibly important problem because, miners probably actually aren't that nice. And so we should definitely be very wary of these problems when we're building applications, right? And so, in general, as protocol designers and as application designers, I think it's our duty to make sure that we consider the worst case scenarios, right? And I guess the point that I'm making is that in many cases, we can build things on first layer scalability solutions that aren't vulnerable to these things like miner censorship, whereas if we build them in second layer scaling solutions, they are. While I agree with you that there are things on first layer solutions that are vulnerable to censorship, and I don't know if we'll ever be able to fix censorship, second layer solutions certainly always are. And that's why I'm hesitant to go there.
So let me just go into the weeds a little bit here. So if you for the settlement problem specifically, right? So zero knowledge proof can actually solve this because it's going to be hard for miner to tell that even which channel you're settling, for example, right? So if you build zero knowledge proof settlement process into this, then unless the miner just massively censor all sorts of channel settlement transaction, it's even hard for the miner to tell which channel you're settling until he processes the transaction, and then you later on prove that hey, look, I've already settled this channel in an earlier block. So you're absolutely right that for layer 2 protocol designers, these kind of things is something that we should definitely think about. That is to make the layer 2 protocol and the associated smart contract more censorship resistant. But yeah, it's a general problem basically.
One thing I'd like to get to before we're out of time is how does interoperability sort of come into the mix of this layer 2 and layer 1?
A bit of a leading question. So I think a lot about interoperability. Work on Interledger, it's about making payments happen across different blockchains, different layer 2 solutions. And so I can, talk for days about why I think interoperability is so important. But one of the aspects is just about user choice and making it so that we can continue to innovate on different underlying technologies while building applications on top that are actually agnostic to what we're using. So The reason why it's so easy to build things on top of the internet is because it doesn't care what kind of underlying networking technology we're using. I think there's a similar parallel where we want to be able to build applications on top of this sort of blockchain stack without being super tied to the specific underlying technology we're using. That said, that's a kind of side note, but I think in general, one of the big aspects with interoperability is that will really improve the user experience of these things. Because today the user experience is, oh, I have this great new blockchain, I'm using a really awesome layer 2 solution, or maybe not, on top of it, can I send you money? And the answer is no, because you almost definitely are not using that same network, and so the user experience kind of stops there. So I think being able to connect these up is very important. While we've been working on that, we've been connecting a lot of different types of solutions and found pros and cons amongst payment channels, kind of off-chain, like side chains and things like that. So could go into that more, but I think we're going to run out of time soon. So.
Another thing I was sort of wondering is, does interoperability somewhat imply scalability?
Yes, I do think you often need scalability in order to get really effective interoperability. And so, for example, with Interledger, the way that Interledger currently works requires a lot of really small payments. You have to sort of packetize payments into small amounts. And if you don't have and very fast ones too, and if you don't have low latency and really cheap payments, you sort of can't have these chains interoperate in this particular way. And the same is true of a lot of other ways of doing cross-chain interoperability, where they're just too expensive to do if you're doing them on the base layer. So I do think trying to solve that problem of scaling often of interoperability often first requires solving a scaling problem. Another thing I'll say is interoperability can give you a kind of scaling where, for example, the Lightning Network is really, when people talk about it as like a single scaling solution, it's really a integrated scaling solution, which is payment channels, and on top of that, an interoperability solution, which is these multi-hop payments across multiple payment channels. And that's, what it gives you is, oh, now I can send Bitcoin to anybody who's on the Lightning Network, ideally, if I'm connected to them. But really, sort of the way that worked is we've got two separate ledgers, and we're providing some interoperability between them.
I think another way to answer that question is also splitting up what we're doing by sort of use case is also a kind of way of adding more scalability. If you look at the space as a whole, it doesn't solve the individual scaling problem of how do we solve an individual ledger. But if we don't try to have one ledger for absolutely everything that everyone is doing in the world, and instead have a little more purpose-built systems, that's another way of kind of breaking up the space.
Just to push back a bit, I think that, so again, we're going to be talking about trade-offs in terms of decentralization and security kind of on the margins here, but I would argue that lots of small application-specific blockchains might be getting too close to not very much security, a lot of scalability, in the sense that if we just kind of naively split up into lots of little blockchains that aren't kind of sharing a validator set in some sense, or sharing a security pool, then we might get ourselves into a situation where each little blockchain by itself is very insecure and easy to attack.
And also, yeah, I mean, and I actually generally am kind of bullish on the idea of application-specific blockchains or plasma chains. It is in sort of the history of computing, we ended up not with a lot of purpose-built hardware that's designed for like this specific application or this specific application. You just have sort of like more or less, one sort of like platforms, computers that are fast enough that you can build sort of and simulate anything else on top of it. And so I guess that's maybe the case for something like sharding, where you sort of have this application agnostic set of shards.
Yeah.
Sorry, go for it. So yeah, I think that's definitely a good point. Just like another 2 cents into this discussion is that basically interoperability again is a little bit loaded word, and I'm not so familiar with the use cases of interoperability, but I do want to highlight one thing that we are pushing for the layer 2 scalability solutions, that is blockchain agnostic, right? So basically platform agnostic is something that we might all want to think about, because in any technical stack, once there's like a layered technical stack, once the interface is well defined, each layer can innovate independently. So that's why we think for this kind of interoperability discussion, we should always think about like blockchain agnosticity into this, basically.
Yeah, so this morning I was working on a blog post called Layer 3 is for Interoperability, and making this exact point that if you want interoperability, you need to start with a blockchain agnostic design and not tie into specific features of the blockchain. That said, I think there's an important point where I think layer 2 solutions actually should tie into very specific features of layer 1, because they should basically use every bit of capability that the underlying system gives them in order to add scalability. But I think that's why you need a separate layer focused on interoperability and abstracting the differences away in order to make that work.
Yeah, absolutely.
We're out of time, but thank you guys for participating in this panel, and thank you guys for listening.
Thanks.
Thanks.